Okay, we're live. So, hey guys, my name is Jan and I'm from DoraHacks, and welcome to our second workshop session of the Akashathon². And before we start, let me give you a bit of background on DoraHacks itself. We're the biggest, largest Web3 developer incentive platform, and it's an honor for us to support the Akashathon², and we're looking forward to seeing all the incredible projects building on top of Akash. And today we're very happy to have here Sean. He's developer relations. Let's talk about the secret track overview. So for the audience, if you have like any kind of questions, feel free to drop them in the chat, and then happy to answer them towards the end. And there will be also another workshop in a week, so feel free to also subscribe to our socials like Binance Live and YouTube. And without further ado, like once you're ready, you can just start.
Awesome. Thanks so much for having me, Jan. Hello, everybody. My name is Sean Conrad. I am with Secret Network Foundations as a developer relations engineer. And I'm excited to just go through with you today our secret network track for the Akashathon. I'm excited about this just because hackathons was my entry point into the Web3 space, first with ETH NYC a couple of years ago, and then HackFS, and then now Secret Network has been running hackathons. We're starting to run them quarterly, and so it's exciting to be with the Akashathon. We did this last year, and we saw some really incredible projects come out of it. So I want to share our track with you today, and really excited to see what everybody builds. I'm just going to share my screen so that we can actually run through the track together. And what we're going to be doing today is I'm just going to be doing a quick demo showcasing something that would make you eligible as a developer to receive a bounty for this track. And secret is we have a $1,000 USD prize for anyone who uses our track in Akashathon. So let's see, I'm going to share my screen. Okay. All right. So yes, if you see the URL up here, we're on DoraHacks page on the hackathon and /Akashathon², and these are the sponsored tracks. So if you navigate to the sponsored tracks tab, you will see the secret network IBC track. And so what our track is we're emphasizing utilizing IBC hooks between Akash and secret for cross-chain functionality. So to be considered for a prize, your dApp must implement IBC hooks between Akash and secret and utilize secret for some kind of computation. We provided a lot of resources here in these docs. We have our getting started documentation for secret network. We have specifically our IBC hooks docs. We have a tutorial using cross-chain randomness with IBC hooks. And we also link to a previous Akashathon secret grant winner repo that used IBC hooks. So if you are a developer watching this, I think these are all the resources you need to get started using IBC hooks cross-chain. But I'm also going to go through a demo here where we learn how to send cross-chain randomness. Definitely check out this previous Akashathon grant winner. This is a really amazing project. Shouts out to Crompston. And he has a really comprehensive README in here if you're curious how to get up your own connection between Akash and secret running. So definitely check out this repository. It's Crompston/IBC-field. And I will let you look at that in your own time. It's a little more complex than what we're going to be doing. But I'm actually going to go through the demo right now just to showcase something that would make you eligible for a prize. So let us do it. So in these resources here, there is a secret VRF tutorial using IBC hooks. So I'm going to click onto that, and we're going to do this tutorial. So an amazing thing about Secret Network is that everything that happens on Secret happens inside of a trusted execution environment, which means that we're able to have confidential computation on chain, on Secret. And we now also have toolkits where you can use this computational, these private transactions on EVM as well as any other Cosmos chain that is IBC enabled. So we have an EVM developer toolkit if you're wanting to understand how to use us for private transactions on EVM, but we also have this for IBC. And that's what we're going to be looking at today, is this cross-chain randomness. So we can generate a verifiable random number on chain on secret network, and then we can send it to other IBC enabled chains. And the sample tutorial in our docs uses IBC hooks, and it does this with Juno network. So I'm going to show how to do that, how to send a cross-chain random number to Juno. All right, so this is really simple. We tried to abstract away as much as possible to make developers be able to get up and running as easily as possible. Something that I've sort of seen as coming into the Cosmos space is that it's one thing to be a CosmWasm developer, and it's an entirely other thing to be an IBC developer. I think there's like a lot of boilerplate code that still has yet to be abstracted away to make using IBC for cross-chain transactions simple. And so that's kind of our goal at Secret, is to abstract some of that away to make it more easy to use. And we were able to do this with the magic of IBC hooks. So to work with this tutorial, what I did is I just cloned down this repo right here. And this is what we're actually going to be working with. So let me just pull up the code. So in this code, we have two CosmWasm contracts, one which is deployed to Secret, and one which is we're going to upload it and instantiate it and execute it on Juno. And then you can do the same thing with a cache. And the idea is just to kind of get the structure in your head so that you feel like you have the resources you need to be able to work with these contracts, and then to be able to hack away at them and update them to your choosing and to your liking. So the contract that we're not going to be actually making any changes today, which is already uploaded on chain on Secret, is this IBC hooks contract. And in this contract, we have all of the boilerplate code to be able to work with IBC hooks on Secret with your chain. So we already have these like IBC timeout messages, IBC acknowledgements. This is just sort of basic boilerplate code that you need to work with IBC hooks. And all of that is explained in our docs and the resources on DoraHacks. So all that this does is we are able to send an IBC message to the secret contract to receive randomness. We request randomness that we then send back to the IBC contract that requested the randomness. So this is already uploaded on chain on Secret. But if you wanted to do something different, like if you wanted to use Secret, for example, as a confidential computation layer, if you wanted to use Secret for private transactions, for example, you could update this to change how you're actually working with this contract in terms of what you're using IBC hooks for. But what it does is just sends a random number. So what we're going to be looking at is our consumer side contract. Let's just close out here so we can see what we're actually working with. And so, yeah, very simple. There's just an empty instantiate message, and there is a request random function and a receive random message. And the way to work with this, all you need to do to work with this on a cache or any IBC hooks enabled chain of your choice, all you have to do when you instantiate this contract to your chain is update the IBC channels that you're actually working with, the IBC transfer channels. So we have Archway commented out here. We're going to be working with Juno, and I'm going to upload this to mainnet for funsies, because why the hell not? All right, so this is the transfer channel for Secret on Juno, and this is the transfer channel for Juno for our chain, which is 48 and 8. And again, if you want to do this for a cache, you would just do this for mainnet for your transfer channels. So we're going to upload and instantiate this contract exactly as it is. And there are already scripts we wrote out in the docs for how to do this. This is using Juno's CLI, so you have to just update this to your chain to make sure that you can do this on your chain of choice. So I already compiled the contract with our make file. What I'm going to do now is just upload this smart contract. So let's do that. And again, all of these scripts are already written out. So we have an upload script, we have an instantiate script, and we have an execute message to actually request that randomness on Juno, right? So let's do this. I already pulled those commands into a README file here. So the first thing we're going to do is just store this consumer side contract on Juno. All right. Confirm the transaction, and then it will return a transaction hash. And then we can just go to a block explorer to actually get our code ID. So let's see, we want to make sure we're on Juno mainnet. All right, so I'm just going to search this transaction hash. Let's see. Where are we here? I want to make sure I'm at the right link. There we go. Okay, so we have the code ID is 4,306. Then all we need to do is just take that code ID and instantiate with that code ID. So I'm going to update that here. And yeah, so the only thing you would actually need to update for you is just your chain ID for a cache, your RPC, and your wallet to make sure that it's funded with a cache. All right, I'm instantiating code ID 4306. Confirming the transaction. And then we should see that transaction hash. And what it should return is a Juno smart contract that has access to the ability to receive and request randomness. So we can execute that. Okay. Great, so our contract address was returned. Let's copy this. And then go back into our execute script. And if you're more comfortable with JavaScript rather than using the CLI, we also, in our tutorial here, if you clone down this repo, in this node folder, we have an execute script with CosmWasm.js. Let me show you. Come on. So this is just what we're going to do now with the CLI, but this is with Cosm.js if you're more comfortable with that. So you can play around with that. Just want you to know that that exists. All right. And so if we go back into this Juno contract, like what it's actually doing. So this is our request random function, and this is our IBC callback, our IBC hooks memo. And we can see we're requesting a random, and we're only requesting one random string, right? But if you wanted to request more, you could, I think up to 2,000 request more. We're just requesting one, but that's where you would update that information here in this callback. And again, all of this has already been abstracted away so that you hopefully have like a really good boilerplate to develop the code however you see fit. All right. So, okay, we want to execute this contract. And just copy it. Okay. So we are now executing the smart contract that we just instantiated. Awesome. It returns a transaction hash. And then let's just look at our contract and the Explorer to see that we actually received the randomness that we requested with IBC hooks. And if you've never worked with IBC hooks before, and this is totally foreign to you, fear not. We also have kind of like a primer in our docs about IBC hooks. But basically, the idea of IBC hooks is that when you send an IBC token, when you initiate an IBC token transfer, you can also initiate a smart contract call. And so that's all that's happening is we're sending the token cross chain. And then when we do that, we're also executing our secret smart contract to send a random number with the receive randomness callback. Okay, so I'm going to pull up our contract address. All right. So we see, I guess like a minute ago when we instantiated it, that transaction hash, and then we see the execution. So let's check it out. All right, here's the actual message itself. And we should see that our randomness was returned as a string. We requested one random string. So this is the randomness that was returned. And we see here, this is the random string that we returned. So pretty awesome, right? Like it's completely abstracted away. This is an example of how to receive cross-chain randomness with IBC hooks with any IBC chain that has hooks enabled. And like, if you want to see what that looks more like underneath the hood, if we go back into the secret contract, we can actually see our randomness function. So here's where like the randomness is actually generated, and on secret, randomness is generated from the block environment. So from our env parameter, that's where we actually are able to receive the verifiable randomness with inside of a trusted execution environment on secret. We get the random bytes, and then we take that and with our IBC boilerplate code are able to send that back to our chain of choice. That is the demo. Are there any questions? I'm not even sure actually to see where they're
So
in the
thanks a
comments.
lot for the demo and the walkthrough. I think let's give the audience some time to digest the information. And in the meanwhile, maybe you could explain, like, you mentioned you've participated at a lot of hackathons. Like, what are advice that you would give to hackers, like about how to build on secret, how to maybe win a prize?
Yes. So I would say the main thing is just don't be afraid to ask questions. And if you have a question, it's probably been asked before, and the answer exists somewhere like on Telegram or Discord. Because something that's interesting about the Web3 space is like in Web2, you have a question. Well, now ChatGPT can mostly answer your questions, but before that, Stack Overflow is like where you would find all the answers to everything. Everything was kind of well documented. In Web3, it's more that you have to go into join the Discord of the chain. So like join secret Discord, join a cache Discord, and search through the chats to see if someone's already asked your question before. And if not, just ask your question in like the dev issues chat on secret. Because there's a lot of really talented and active developers in our community who are here to help you. And so just, yeah, the speed, especially in something like a hackathon where you have a limited amount of time to create your project, you don't want to get stuck just like getting bootstrapped, working with a new network or like a new protocol like IBC hooks. So just ask questions and somebody will get back to you. The other thing I'd say it's good if you can have a team member, so somebody to work with just to kind of keep you on track and help you to stay motivated. And yeah, we also, Secret has a developer call on Discord every Monday at 1 p.m. Eastern time. So if you just join our Discord, which that's also linked in the resources on DoraHacks, from there you can join our developer call on Mondays at 1 p.m. Eastern time, and developers in our community will be there to answer questions live. So like when I was starting to learn on Secret, I was originally an EVM dev who came to Secret. And so I learned Rust, I learned CosmWasm to become part of the Secret community. I had tons of questions, and I would just go on this call every Monday and just screen share my code, the issues I was running into. And it just kind of like 10x'd my development, being able to ask questions live and get feedback live.
Yeah, that sounds very good. So like if you haven't joined the Akash and Secret Discord, please join their Discord and also join the Secret community calls or developer calls on Mondays.
Yeah. And if this is your first time working with IBC hooks, definitely check out this repo from the previous winner, because I think that like if you're able to implement what they implemented for your own use case, what they did is they created a cross-chain game. Pretty cool.
What else are you excited about? What would you love to see at this hackathon?
What we're really excited about is just like people utilizing hooks, and figuring out novel use cases between Akash and Secret. Just still, I think what we see so often in the Cosmos is that like the whole idea of the Cosmos, I think the promise of it is that we're interchain, and our blockchains are able to communicate with each other, and through that create novel use cases that you can't in other blockchain ecosystems. And so, but I think because like it's still, every chain has its nuances that kind of make it its own developer experience, but with new IBC technology like hooks, some of these complexities are getting abstracted away. And so my hope for this is just that maybe if you're a developer who hasn't used hooks before, you find a way to use them with Secret, and in that become onboarded to Secret, become onboarded to Akash, and just add a new tool to your toolkit as a developer.
Yeah, that sounds very good. Is there anything else you would like to mention?
I don't think so. I think just, yeah, check out Secret's docs. They're very comprehensive. We have a lot of examples, and we're adding to them all of the time. And yeah, and so like one thing we're actually building out right now is a confidential computation layer for the entirety of the Cosmos. So similar to this example that we have with randomness, we're also building one where we show how to do this with just using Secret for private transactions. So just, yeah, stay tuned for that. But yeah, we're very excited to be partnered with Cash for this. It was a great experience last year, and looking forward to seeing all the developer talent that comes through this.
All right, so Sean, so thank you so much for the workshop. I guess the audience learned more about the Secret track overview. And yeah, like we're super excited to see all the incredible projects building on top of Akash and Secret Network. There's more workshops happening, so feel free to subscribe to our socials and stay tuned.
Awesome. Thanks so much, Jen.
All right, take care and see you soon.
Take care. Be well.